Okay, let's see, we got a few more. Oh, shoot. All right. So anybody else that comes in, I'm going to have to get them at the 15-minute mark. Let's share the screen, and we'll start off here. Let's go ahead and hopefully that doesn't crash it. So I know how it likes to do that. Okay. Come on. All right. So greetings, scholars. Greetings, YouTube. Let's see. All right. So I know it's not the same for you. I know this is Wednesday for you guys, but this is my Friday. So I'm just like, let's get it. Let's get this over, you know. Let me see. There's no real announcements. We're at the end of week 7, you know. Main 2 objectives. 1, making sure that you're making your way through the items that's on Pearson, right? You access through Blackboard. You're making your way through those items. I did go ahead, you know, all the homework and quizzes are available for the entire semester, so you can get ahead. Also, the recording, the lectures are available, so you can actually watch those in advance and just go ahead and finish this stuff. Be done with it, right? Get it out of the way. So that way, the only thing you're waiting on are my exams, right? The other objective is for this class, you want to make sure that you've linked up with Dr. Lamar and you've been following her instructions. I want to say at the midterm, I think she has her grade book set up in Blackboard, right? So I think I'm just going to kind of let that be. But when I go to calculate grades, whatever grade I see that she has for your lab, I'm going to scale that so there's 10% of your overall grade. And then our items is I'm going to scale it so that it's 90%. So basically what I do is like, I don't want to calculate grades until after exam 2 is due, right? So exam 2 should become available this upcoming Sunday morning at 11 a.m., you know, just on a auspicious time or whatever. It'll be available for 7 days and be due the following Sunday at 11:59 p.m. So after that Sunday is when I'll calculate midterm grades based on the information provided for me from Dr. Lamar and whatever I see that's on Blackboard. Now, just as a reminder, so nobody freaks out, but like, you know, the midterm grade, all it is a snapshot of where you are at that moment in time. It has no bearing on your final grade. So if you know you're behind, you know, it's going to reflect in your midterm, but as long as you get that stuff submitted before the end of the semester, you know, if we're at the halfway mark, that gives you a little over 8 weeks at this point, right? And it seems like a long time, but you're going to blink your eye and it's going to be over, right? So my recommendation, just go ahead and get this stuff done and out of the way. So that way you only have 2, after exam 2, you'll have, if you've completed everything, you'll have two things you're waiting for, basically exam 3 and the final. As always, this is a remote asynchronous course, so you're not obligated to stay. If you've made it into my Zoom right now, it's funny because I think I'm saying that less for you guys and more to remind myself to, like, you know, it's okay if they leave, because it used to irritate me, but then I'm like, no, that's why I made that change. Instead of getting upset about it, you know, just allow them to be adults, right? I know it's kind of weird, but basically the structure that I do is like, I'm treating you guys like adults. I know you know, a lot of you guys are right out of high school, but at some point you have to start being accountable for yourself, right? You know, so that's why I make myself available and I kind of ease the reins a bit and like, okay, I'm gonna let you make a decision. I'm gonna let you devise a plan, you know, yada, yada, yada. Okay. So always, if you have questions, comments, or concerns, feel free to unmute yourself. That's the best way, you know, to get my attention. Or if it needs to be a little bit more, you know, private, then you can put it in the chat. And I do check the chat periodically. Okay. So today, what I would like to do, I know we were working through the end of chapter 1 last time. We made our way through as much of the lecture as we could. Again, the remainder of the lecture is already pre-recorded and it's available. So what I would like to do today is start again. Okay, let me see. So in this example, we're given that f of x is this, g of x is this. Okay, so we're combining functions, right? I think I would like to take notes here. Okay, so let me And again, I'll check for the latecomers at about the 15-minute mark. I might be a little late, but if you don't want to miss the opening announcements and you want to secure yourself, I mean, I know I'm preaching to the choir because you guys are here, but the best thing is to get into my waiting room 5 minutes before the start of class. That way you don't fall into that second wave that, I know that sometimes students are in there and then they get tired of waiting, so they leave, and then they don't realize like all you have to do is just keep waiting. Just be a little bit patient to get your credit. But that's life. Again, that's part of come on. I don't know why. Okay, that's part of being an adult. All right. Okay. And it's like, with you guys, because we're first thing in the morning, especially because I don't have to commute, like I just feel the most fresh. I know after lunch, people have eaten, this stuff could be kind of tough to listen to. But it's okay. I mean, that's the challenge. That's the challenge that we have before us. Okay. So we're given this f and this g, and basically we're evaluating composite functions, right? So for instance, for part A, we have f plus g of -2, right? So let's kind of mimic what we were doing during the lecture. Okay, so this means we got f plus g of -2. This means we do f of -2 plus g of -2, all right? So let's do f of -2 first, okay? So we replace our x with a blank set of parentheses, and then we're gonna plug in the -2. Notice how the blank parentheses helps us to group the negative properly, so we're less likely to make a mistake. Notice that here, if that parentheses was missing, it might look like -2 minus 2, and that would be wrong, right? Okay, so if we keep going, this is gonna give us what? 4 plus 4 is 8, okay? So then let's go ahead and do g of -2. So g is 9 minus x cubed, okay? That's gonna be a -8, double negative is positive, 17, okay? So then, to go back to the original, f of -2, we got 8, we got plus g of -2 is 17. 14, 15, 25, all right? 25. Okay, so we got 25 for that. Okay. And again, I'm just trying to make my way through as many questions as I can. If you would like me to work on a specific one, it just has to be requested, right? G minus f of -1. And also, if you've emailed me and I haven't responded, then just ask me during class, right? Because I kind of be busy. Whoops, that's not a plus. Yeah, the best is just if I don't respond by the next class, just ask me during class. I still haven't confirmed whether we have Monday off. I think that we do. I'll check it at some point and I'll send an announcement. If Monday is a holiday, we won't meet. Pearson is still going to operate like normal, but we just won't have the live session at that time. Okay. All right. So working on the next one, just for the no, that's too bright. Okay. So same kind of deal, right? We have g minus f of -1, so this means g of -1 minus f of -1. So let's do g of -1. Okay. I mean, I could use a calculator. Okay, just for the sake of time, let's try this in the calculator, right? Let's see if we can get it going a little bit faster. So let's reload and refresh. Okay. So now, suppose, we see how to do it by hand, but I want to go a little bit faster, right? So let's go to y equals. In the first slot, I'm going to put f. So I got x squared minus 2x, okay? And then in the second slot, I'm going to put g, which is 9 minus x cubed, okay? I'm going to go back to my home screen. And just to confirm that we did A properly, now we said A was F plus G of -2. So if I wanted to do that in a TI-83 plus, I'm going to use the pink and green part that says F of -2 plus G of -2, right? So I'm going to call on the variable if you need me to explain how I'm doing this, because I've done this several times. So that's the only reason I'm not explaining it right now. So we're going to say F of -2, okay, plus, now I'm going to go back to variables. But now I want to call on the second function, which was my G, and I want to say G of -2. Oh, I want to try something. Now we should get, when we did it, we got 25. Now I want to try something. I'm gonna try to make it look exactly like the original. So instead, let me just call on what I typed before. And I'm gonna try 2 different ways. Let me see if I get rid of this stuff. Okay, will that behave? Will it say 25? Okay, let me try one other thing. So if I insert, what if I put this in parentheses and insert, what if I put it in parentheses like this? Let's see if that works. Nope, it gets worse, right? So we can see that the only one that should work is the first formation, right? There might be some other way to do it, but okay. So now we confirm the first one. Let's go ahead and do the second one by hand one more time just to make sure that we got this going. Okay, so this is going to be equal to 9 minus x cubed, but x in this case is -1. So that's going to be 10. Okay, and then f of -1, x squared minus 2x. Is that it? X squared minus 2x? Okay. -1, -1. That's going to be a 1 plus 2 is 3. Okay. So then it looks like this is going to be 10 minus 3 to give us 7. Okay. Copy. Okay, so when we do it in the calculator, we should get 7. Okay. So that's just to confirm. So we need to say G. So let's go variables. Nope. Didn't do that right. Variables. We want G of -1 minus variables F of -1. Okay, and we should get 7, right? Okay. So now I feel confident in that. So now what I'm going to do is hop back this one, right? Let me finish this one out, and then I'll look for anybody that's late. So I think for the first one, we got what, 25. Okay. Let me get rid of that. Turn it off. I think for the second one, we got what, 7? Can I show my no keyboard? Okay, maybe I need to turn that back on. It's automatic. Oh, that's not working either? Okay. On screen keyboard, just turn it on then. There it is. I think we got 7 there. Okay. So now let's do this next one. So we got f times g of -1. So that should be f of -1 times g of -1, right? So we're just gonna do it in the calculator just for the sake of time. Variables. So f is the first one. So f of -1 times, now I'm gonna do this one, g of -1, right? And we're just gonna trust it. We got 30, so let's go with 30. Okay. And then let's go ahead and do this one. G of 3 divided by f of 3, right? So G was the second one. That one. G of 3. Then we're going to say divided by f. F of 3. Okay. And we get -6. Come on. So then let's put -6. Okay. All right. that was fun, right? Got another one. This is why I decided to switch to the calculator, because these can be time consuming doing it by hand, which is nothing wrong. But with this, the nature of everything being time sensitive, let me stop the screen and let me check for any latecomers. Let me get these two right here. Okay, thank you. And then this student. Oh, nope. Here. Okay. Let me check the chat as well. Okay. Hang on, let me get the student. Okay, so let me see. I got this, someone typed in the chat. Let me see, it says, I read your email, sorry I forgot to reply to it, but when you said all assignments are due basically on December 9th, does that include exams that I've missed? Okay, right? Yes, right? So the structure is, suppose, let me go ahead and share my screen. Let's kind of chat right here. Let's clear all this out for right now. Okay, so the structure is, all assignments, that includes exams, quizzes, and homeworks. 1, we get unlimited attempts. 2, you can work on any assignment past the due date all the way up until the end of the semester, which is basically that Friday at the end of the week of finals at 11:59 p.m. And all assignments, there's only a 10% late penalty, right? There are just too many things that can happen just so many random things that can happen in an online course. So some of it's legit, some of it's not. I just decided to group all those things together, and that's why I did minimal penalties, right? I feel like you shouldn't get full credit for submitting late, but I feel like 10% is reasonable. And I've had students do that. Like they kind of didn't get full access until like late, and they submitted what they needed. They walked away with either like a C or a B. It's difficult to get an A at that stage, but I mean, I think that's okay. If they found a way to get it done, and there are different ways. My recommendation, try to get stuff done as early as possible, but if you can't get into that position, then there are other ways to kind of get it done. Okay, hopefully that answered the question. And I think let me check. I think we got everybody. Let me check one more time just to something saying check. Yep, see? He almost didn't get a credit. See, he had missed the second wave, but it's fine. Some said check, so I checked. Let me see. Yep, cool. Okay, let me go back to sharing my screen, and let's hop back to Pearson. All right, let's do another one. So we've only done one. You see how long it took us, right? But that's why I switched over to the calculator. Once you know how to do it by hand, then the calculator revs it up, right? Okay, so let's give this one a go. Now, let's see if we can do this one in the calculator. So I'm going to go to my y equals, and I want to clear these two out. Okay, now my f in this case, now you do have to type it in properly. I'm going to say 1 divided by my square root. Now the square root acts as its own grouping symbol. So, we're kind of good there, right? That should be typed properly. Then for my g, I want 5x plus 4. Okay, so the first line is f, second line is g. I'm going to quit, okay? Clear. So now for part A, we have f plus g of 2. So that means f of 2 plus g of 2, right? So I'm going to go to variables, call on my f. We want f of 2. We're going to do plus, call on my variables. Now we want to call on g. Let's go back. G of 2, okay. All right, so we saw how to write this out. We got 14.5 using radicals. Shyster. So this might, some of them, if we get like, it says an exact answer using radicals. So some of these we might have to work out, right? We'll use the calculator when possible. This one we got 14.5. Okay, let's just go with it. That is exact, okay? So again, if we get a long decimal, we're gonna have to do it by hand. Let's try f minus g of 0, okay? F minus g of 0. So f was the first one. F of 0 minus g, which is the second one. G of 0, okay? See, we got a long decimal, so that means that we have to do this one by hand, right? So let's get a copy of this guy, because it says an exact answer. So if we try to put that decimal in there, it's not going to give us credit because it knows that we're probably using the calculator, right? So they're trying to really see, okay, do we know what we're doing, or are we just like getting by? All right. All right, let's give this one a go. Cool. Okay. Boom. That's good. All right. Okay. So fine. So we're working on B, right? So this one we do need to do by hand. So then for B, again, we're starting with F minus G of 0. Okay. Again, this means F of 0 minus G of 0. All right. Okay. So let's go ahead and do F of 0 first. I guess we can work down here. So then F of 0 ends up being, let me see, 0. Okay, so we got our x plus 2 square root under 1, and our x is 0. So then this is going to be 1 over the square root of 2. Okay, that's the result that we got there. So then let's go ahead and do g of 0. Okay, g of 0 is 5x plus 4. 5x plus 4. So then that one is 4. Okay. So to finish it out, f of 0 is 1 over the square root of 2 minus 4. Oops. Okay. So that's the exact result. Okay. Now we can confirm this. Can we paste? Yes. Awesome. So we got 1 over the square root of 2, 1 over the square root of 2 minus 4. We should get the same decimal. Okay. So then let's try submitting it on Pearson. 1, we got 1 divided by square root of 2. Thank you. 1 divided by the square root of 2 minus 4. Okay, let's go with that. Right? So again, if we tried to submit that long decimal, it was going to mark it wrong because it says, the instructions say, type an exact answer using radicals as needed. Okay, let's see if we can do the next one in the calculator. That'll save us a lot of time. F times G of -1. So let's call on F. That's going to be F of -1 times, now we want to call on G of -1. Okay. Come on. Oh, we got -1. So it looks like that one should be -1. Let's try -1. And God is good. Okay. All right. And let's see what happens with the last one. Now we don't know until we go to do it. We could, yeah, let's just edit the one that we did, right? Instead of F of -1, it's now F of 1. Instead of times, it's divided by G of 1. Okay. Let's see. Darn. All right. So 2 of them we can use our calculator, and 2 we have to do by hand. So let's go back here. So then this is part D. We got F divided by G of 1. Okay. This means, let me make sure one more time. Okay. This means F of 1, come on, divided by G of 1. Okay. So let's do those off to the side. F of 1. So we got our x plus 2 under square root under 1. And That's going to be 1 over the square root of 3, okay? And then let's go ahead and do g of 1, 5x plus 4, so that's 9. Okay, so then we get, oh, shiesta, okay. So we still got a little bit more we need to do, right? So we need to say this is going to be equal to 1 over the square root of 3 divided by 9. When we divide by fractions, we do keep, change, flip, right? So 9 is the same as 9 over 1. If you do keep, change, flip, this is going to be 1 over 9 times the square root of 3. Okay, let's go with that. Now, we could check it. I'm just going to use Pearson to check it just for the sake of time. 1 over 9 times the square root of 3. Okay. 1 over 9. So we got 1 divided by 9 times the square root of 3. Okay. That was an adventure, right? Let me take a moment. I just want to check. Okay, chat looks good. Let me see if we got any stragglers. Okay, looks good. Okay, cool. All right. Let's try to get some more in there. We got a solid 20 minutes. Let's go to the next question. Given f is this, g is this, find all of this. Okay, so we're not evaluating here. Okay, I'm curious. I might be able to do it, then determine the domain. Okay, so with this one, right? Notice that f, let me see, I'll just go like this for right now. Notice that f is what we call a polynomial. Polynomial is a finite sum of monomials. A monomial is something where you have like a real coefficient times some variable to an integer exponent, a non-negative integer exponent, right? Like, so 2x plus 2, and you'll start to recognize polynomials. That's the short term of it. But polynomials, the domain of polynomials is all reals, right? So f, the domain, because basically if you look at f is a diagonal line, right? The y-intercept is 2, has a slope of 2, that's y equals mx plus b. So that graph is a diagonal line. That means the domain is all reals. If you look at g is going to be a parabola. It's a U-shaped curve that's been stretched vertically by a factor of 5. But even if it's a U-shaped curve stretched vertically by a factor of 5, the domain is still all reals. So the domain of both of these is all reals, right? So the only one that really should be in trouble when it comes to domain is that f divided by g, because we cannot divide by 0, okay? So domain should be fairly light here. Most of them should be all reals. For the first part, f plus g of x, so we're just gonna say f of x plus g of x. So this one we can't do in this calculator. So we're just gonna say, it's just basically add the terms together. 5x squared, okay, plus, where's my plus, keyboard is charging. 2x plus 2, 2x plus, where's my plus 2, 2, okay. I think that's the first one. I just said f plus g. The domain should be all reals, because all reals intersect all reals is all reals. I'm just gonna go with it. F minus g, so we're gonna say f minus g, all right? So it's basically gonna be, okay, let's just do it the simple way. 2x plus 2, 2x plus 2, minus, we don't have to distribute the minus in this case, so it's gonna be minus 5x squared. Okay, let's go with it. And again, there's no restrictions. It's still just a polynomial, so it's going to be all reals. Okay. F times g. Oh, there it is. Okay. So if we're doing f times g, we probably should distribute that 5x squared. 2x plus 2. Okay, it's there. So 5x squared times 2x is going to be 10x cubed. So we got 10x cubed think it's plus 5x squared times what, 2? 10x squared. So plus 10x squared, okay? Now if I need to write these out, and again, that's still just a polynomial, so it's going to be all reals, okay? Okay, f divided by g. So f, okay, I'm gonna go ahead and use my keyboard. It should have enough charge for, no, we only got about 10 minutes. Let's do this. One. Do this really quickly, and I'm gonna suppress that. Just turn it off. Okay. So then f divided by g. Okay. So I'm just gonna do it like this. I'm gonna do my division. F is 2x plus 2. Can I just, nope. There we go. That's a little bit better. There we go. And then on the bottom, we got 5x squared. I'm gonna just leave it as 5x squared, okay? Now, the restriction here is, this is a rational function, right? It's basically like a fraction. The main thing with fraction is we cannot divide by 0. So we want, basically everything is gonna work except 0. We're gonna throw 0 out. The only one that shows everything except 0 is this one. Because if you plug, when x is 0, it makes the denominator 0, and it's no good. We got right at about 10 minutes remaining, right? So let's try to get in there what we can. We got these guys and their domains. Okay, f plus g. Okay, that one looks pretty straightforward. So it's just going to be x to the power of 3. There we go. Plus 5x squared, like this. Cool. Minus 3x. That's not an x. Plus 5. Okay, that looks good. All right, it's a polynomial, so it's going to be all reals, which is c. Okay. And it helps that the originals were both polynomials, so, you know, it makes it a lot more simple. F minus g. Okay, so notice that there's no negative to distribute in g. So the simple thing here is 5x squared minus 3x plus 5 minus x cubed. Okay, that's not clear, you know. Okay, and still a polynomial, so we're gonna go like this. So again, I know I'm going a little bit fast. I'm just, because it's a recording, you can always go back and watch it again. If we're saying f times g, let's distribute that x cubed. Okay, so that's gonna be 5x to the 5th. It's doing that thing. 5, there it is, 5x to the power 5 minus 3x to the 4, 3x to the power of 4 plus 5x cubed. Okay. All right. Let's go with it. And so all reals, no restrictions. And then the last one is f divided by g. Right? So, okay. Same kind of restriction. We're going to hit divide. On top, we got basically f, 5x squared minus 3x plus 5. And then on bottom, well, we're cooking now, boy. This keyboard is tricky because it's like, I can't just use the directional pad because then it starts treating it like a tab and the cursor jumps all over. I was like, no, I just wanted to go down or to the side. So then basically I had to hold control when I use the directional pad to get it to work. Now again, we can't divide by 0. X makes this 0. I mean, 0 makes the denominator, when x is 0, that makes the denominator 0. So we want everything except 0. So then that's going to be C, right? Because again, the only restriction there is we got to throw out any x that makes the denominator 0. Okay, we made it. Man, we got a ways to go. We've only made it through almost a quarter. Right, about a quarter. Let's see. This is F. This is G. All right. It is actually for the domain. That's fine. Let's see if we can. Let's just do what we can do. F plus G. So then, let's do this. Let's say x minus 7 plus square root of x. Okay. Now, with that final one, the only restriction is we can't take the square root of negative. So that means x has to be greater than or equal to 0. So then if we can be equal to 0, that means we use a bracket 0 to infinity. Now, I feel like there should be questions, but, it's okay. F minus G. Okay, F minus G, right? So notice that that minus is in front of G. We need to distribute that negative. So then if we write F first, that's going to be square root of x. Okay, let's get out of the square root. Now we have to distribute that negative, so that's going to give us minus x and a plus 7. Okay. And then again, the only restriction is we can't take the square root of a negative, so it's the same kind of deal. 0 to infinity and beyond. All right. F times G, let's distribute that square root. So F times G, it looks like it's going to be x times the square root of x, get out of the square root, minus 7 times the square root of x, okay? And then again, the only restriction is we can't take the square root of a negative. So then same deal, 0 to infinity. Okay. And then F divided by G, okay? So on top, we have the square root of x, and then on the bottom, we have x minus 7, okay? So the two restrictions here. Not only can we not take the square root of a negative, but we cannot divide by 0. So normally it would be what? We're gonna have to adjust this a bit. Normally it would be 0 to infinity, all right? But we have an added restriction. We got to throw out the x that makes the denominator 0. So I think when x is 7, that makes the denominator 0. So we got to throw out 7. So within this set, we want to keep this set, but we got to throw out 7. So we do that in the following way. So we're going to go from 0 to 7. If we're throwing out 7, that means 7 gets a parentheses. We're going to say cup or union. And then again, we're starting on the other side of 7 on to infinity, right? So this is the same as the original set that we had before, where it was 0 to infinity, but now we wanted to capture throwing out 7. Okay, I know that's a little bit intense, but we got time for one more. It depends on how long it takes. This will probably be the last one. Use a diagram to the right to evaluate. G compose F, and then evaluate these guys. So X to F is that. Okay, G compose F. So first, okay, so basically G compose F is F inside of G, right? So we do F first, simplify your answer. We might need to write this one out. Yeah, let's write this one out. So this will definitely be the last one. Let's see. Let's get a copy of this guy. This is fine. Okay. So here, there's good. This will be it for the day. We're gonna take this. Come on. Right here. Okay, come on. Okay. So it's being totally temperamental. There it is. Okay. All right. Actually, let's just go down to the next page. Okay, we're here. Okay. So now we have that. Let's do it like this. We have f of x is x squared minus 3. We have that g of x is 2x plus 9. So now we're kind of doing composition of functions. That open circle, right? That open circle here, again, don't confuse that. That is not multiplication. That means the second function inside the first function. Composition, that's f composed g of x. That means the second function inside the first function, okay? So then g compose f of x, this means the second inside the first, this means g of f of x, okay? So then that's gonna be g of, but our f of x is this x squared minus 3, okay? Okay, so basically what we're doing is we're writing g as is, but we're replacing all the x's with the fuchsia thing, all right? So then this is gonna be, now g of x, and first we're gonna replace each x with a blank parentheses, is 2x plus 9, and then what color goes in there? Fuchsia. It's x squared minus 3, okay? So then if we expand this, like basically distribute here and combine like terms, it's gonna give us 2x squared minus 6 plus 9. So then we get 2x squared plus 3. Can I just paste? Awesome sauce. Okay, so let's go with that. I see the time. I'm trying to get you guys out of here. 2x plus 3. So let's see. Okay, and then okay, and I'm gonna show you how to do the second part in the calculator. Actually, 2x plus 3. If the final is 2x plus 3, we don't need the calculator. Okay, let me see. Maybe we made a mistake. Let me go back. Oh, 2x squared plus 3. I still don't think we need the calculator because we have the simplified form. 2x squared plus 3. Okay. So then g of f of 2. So basically just plug a 2 into that answer. 2 squared is 4. 8 plus 3 is 11. Okay. Negative 3. 9 times 2 is 18. Plus 3 is what? 21. Okay. And with that, that brings us to the end of this session, right, guys? Okay. Let me go ahead and at least the things that I was writing, I'm going to go ahead and make a PDF available for that. Are there any questions? Any questions? Okay. Let me let this finish loading. So you should receive a PDF copy of what we were working on today. As soon as this bar finishes loading, let's try one more time. Let me check. Okay, there is something in the chat. I'm gonna stop sharing the screen real quick. Number 19. Okay. I don't mind doing 19. I'm gonna go ahead and do 19. But if you have to go, I'm not gonna keep you. You're welcome to leave. I'm gonna go ahead and take some time since it was requested. Let's go ahead and do 19. 19 should be this one. Oh, is it 19? So it's one more. Okay. Let's see. So it says you work in a department store which employees are entitled to a 30% discount on their purchases. You also have a coupon worth $20 off any item. Okay, yeah. We need to take some notes on this one. So like this. Oh, Gizmo is here. My neighbor's dog is in the background. I mean, he is just like walking back here like he owns the place. It's so funny. All right. So let's take this. I mean, it's a cute dog. He don't bother nobody. He's my dog's best friend. Like they just like two peas in a pod when they running around together. It's so funny. Okay. All right. says we work in a department store where employees are entitled to a 30% discount off their purchases. And we have a coupon, right? So I don't know what color, coupon. Okay, discount. We'll let the discount, we'll go with this. That doesn't pop. Let's do this color. So we'll let this be our discount, right? A 30% discount. So say they buy something. Instead of paying 100%, they're going to pay 70%. If it's a 30% discount, they're going to pay 70% of the total. So we capture that by whatever it costs, we're going to say times 0.7. So X is the cost of each item. The discount they get is 70%. Okay. We also have a coupon worth $20 off any item. So coupons, C makes me think of clementine, which is like an orange. So we're going to let C be a coupon off, right? So if X is how much each item costs, then they're going to take $20 off the cost. Okay. Write a function that represents the price of the item after applying the discount. Okay, write a function that represents the price of the item after applying the coupon. That's fine. So we got both of those. Okay, let's go ahead and submit those two. So if we hop back here, after applying the discount, so they're going to pay 70% of the total. If it's 30% off, okay, they got to go like this. So it's going to be 0.7 times X. Okay. And then $20 off is going to be X minus 20. Okay. Now, the cost if the clerk applies the discount first. I think we can do it here. So let's say X is the original here. Let's do like this. Let's do a set of parentheses. Now we're going to do some calculations here. Suppose X is how much the thing costs. It says the cost if the clerk applies a discount first. So if they do the discount first, there it is. If they do the discount first, that means they're going to be paying 70% of the cost. And then after that, they're going to say minus 20. Okay. So then C, use the composition of two functions to model the cost of item plus and then the coupon. Okay. I think this is it, right? All right, nothing to distribute. Let's go with that. So if they apply the discount first, it looks like this. Okay. So then intuitively, now we should probably do what? The coupon first, right? So what I'm going to do, start with a blank set of parentheses. Now, that way, whatever we're doing first goes inside the parentheses. So we start with the cost. If they apply the coupon first, it's going to be minus 20. And then whatever answer we get there, we're going to say basically times 0.7. All right, we're going to take 70% of that. So 0.7. Okay. If you distribute that 0.7, the first one is going to be that. Let's see, 10% would be 2. Hey Siri, what's 70% of 20?
70% times 20 is 14.
14, right? 70% of 20 is 14. So then this becomes a 14, and we can lose that parentheses, okay? All right. So now notice, there's a difference, right? When we applied the discount first, we had 0.7 minus 20. When we apply the coupon first, we had 0.7 minus 14, right? So the 0.7 is consistent, but with the one of these, one order gives us a greater discount. And it looks like the first one gives us a greater discount. So using composite functions for C and D, find out how much more if they apply, right? So the greater discount comes from C. If they do D first, they're going to be paying what? $6 more. All right, because the 7s cancel, and the difference between those is 6. So if they do D first, they're going to be paying $6 more. Okay, that was an adventure. I don't know about you guys. That was fun though. That was fun, right? I be holding back, right? I'm trying to get you guys up to speed. I mean, not that was anything impressive, but it was just fun, like because you actually think about it. You actually got to think. Like I get a kick out of one thing I really want to start doing. Okay, I'm a gamer. I haven't started streaming, but I game kind of like around the clock. Like I'll be losing sleep on some of these games. But most of my games are strategy games. It's a lot of like capture the flag, where it's like a dynamic modern mobile chess. That's what these games are like. So you have like tanks, you have fighters, you have long range attackers, and then depending on the game, you have some other things mixed in there. But what I really want to do is like, okay, let's see what kind of research has been done on like the actual game of chess. And then can we take some of that research and apply it to some of these games? You see what I'm saying? So then if it's actually true, you can like dominate on these games. But the thing is less, because if you have these applications in the games, it's not really about the games. There are real world applications. Look at what's going on with the war in Ukraine, right? It's strategy, it's positioning. A lot of the stuff is based on positioning and mobility. You know, the first rule of combat is like, you got to be able to move. You can't move, you're going to be a sitting duck. Secondly is, you know, there are ways to move where you can get out of range but still be within range. Like when they attack, if it's a linear attack, if you circle the target, you're going to be out of range of his attack but still within range to do your own strikes, right? You know, it gets interesting. It gets really interesting. Okay, so let me check here one more time. Okay, the chat looks good. So if there aren't any burning questions, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your weekend, guys. All right, take care. Yes.
I just wanted to make sure my attendance credit was good too, because I came in a couple minutes late.
Yeah. As long as you make it into my Zoom, then I give you credit, right? Because that's how it goes.
Okay, thank you.
Pleasure. Any other questions, gentlemen?
Can you share the link? If you start streaming, can you share your Twitch with us, please?
Oh, Twitch. Okay. Does any of you guys stream? Anybody on the call right now still stream? Because I need some help, right? With that, I need help. Okay, there's a couple of things. I've started to play more games, but the main games that I play is Dragon Ball Z Dokkan Battle, right? It's a RNG, you know, it's kind of relaxing, but they're starting to rev up. I was like, crap, you know, so I was like, that's one level. But then the games that I'll be referring to a lot of times, the main one is this game called Mobile Legends, Bang Bang. Now they were under some fire because they basically plagiarized. They copied this game called Wild Rift, and Wild Rift was suing them. I mean, it was like so many things that were like identical, as they just changed a few things here and there. So they had to revamp. But Mobile Legends is a lot of fun. And then so now recently I discovered this game on Apple Arcade called Transformers. And it's just like a mini Mobile Legends. And the matches be like 5 minutes. Mobile Legends, the matches are like 30 minutes. And that shit, excuse my French. See, that's my gamer coming out. But those matches are intense. They're 30 minutes. You know, you play one of the pieces and you have to team up with strangers. And like, you're depending on the strangers to do their job. If somebody doesn't do their job, you're all screwed, right? But Mobile Legends has another version. It's called like Mobile Chess, where you control all the pieces. So in the regular gameplay, you're one of the pieces. In the chess version, you control all the pieces. Transformers is like the chess version. This Transformers game on Apple Arcade. It's fun. And the reason I downloaded it is because both Mobile Legends and this Transformers game, they both have Optimus Prime. I was like, I played Optimus Prime and Mobile Legends in one game. You know, being an Uber driver, driving my teammates around, that shit is so funny. And the funny thing is, I actually do Uber in real life. So it's like there was a stretch where I would drive all day in real life, Ubering people, doing Uber Eats and all this other stuff. And then I would come home and play as Optimus Prime. I'm about to play him right now. I would play as Optimus Prime and be driving my teammates around the board. And like once I crash and do whatever I do, I goes back to the base and I'm waiting on the next wave. But then, yeah, so like I said, I discovered this new Transformers game on Apple Arcade. It's included in my Apple subscription. And it's fun. I was like, oh man, this is like that. So the next level is actually do some research on what kind of research has been done on the game of chess. And then let's translate that research to these modern games. And I mean, honestly, the stuff that we talk about in here comes into play because it's a lot of it's geometry, a lot of it is timing. Sometimes I bait opponents with certain things. I mean, it's very, very dynamic. And it has applications. The stuff we talk about actually has applications in the games, but then the games have actual applications in reality. Not only in war, like if you're trying to, like if you think of like the game of Monopoly, like if you think of like the United States, and you're trying to like take over, and like say, like if you think about McDonald's, what industry do you think McDonald's is in, right? At first interaction, you might be tempted to say, "Oh, McDonald's in the restaurant industry." No, they're in the real estate industry. They don't really care that much about the quality of their food. They want to be consistent. They want to have a consistent output as far as the quality, but they're more about buying as many properties as possible. I don't know if I've seen it where, a McDonald's is on one street, you go like half a block down the road, there's another McDonald's right there. You're like, why are there so many McDonald's? Because they're trying to have, and this is nothing new, but they're trying to have as many locations as possible. I mean, worldwide and everything. So it's strategy. It's all strategy. It's so interesting. I feel like a little low key like Shikamaru in like Naruto, right? It's kind of like that. That's my vibe. That's what I do is I just sit around and strategize. It's fun. It's so much fun, especially when it's successful. It's frustrating when you lose because you put so much energy into it. But yeah, so so the support that I was asking for was like basically I need like a logo, something that encompasses, because I honestly have 3 different channels. I have the channel that I do with you guys for like education. I do have a gaming channel, but I just, for some reason, I won't stream. I just need some encouragement there. Like when I've tried streaming in the past, something I'm not doing right because it's kind of laggy. I haven't figured out what I need to do, if I need some new equipment, which I probably do, but how to make the stream look a little bit better, look clean and professional. And then my 3rd stream is I have a wellness stream where it's like meditation and stuff like this, right? So I don't know if I can have like a central hub that encompasses all of this, but I need like a logo. I would rather have like a logo that would encompass all 3 of those. And there's a dark side too, but I'll leave that there. But then I need like an intro and outro. Like, so I need somebody that like can show me how to create these channels and streams, right? Because I'm going to keep doing the stuff that I'm doing, but my mind was like, okay, if I'm a gamer, I need to find some way to capitalize on this. I need to find some way that I can not only help people, but it's fun, it reaches people, it connects with people, and find a way to make it constructive so that I can encourage others, right? Because to me, one of my goals is not only to be free, but to free as many people as possible. I don't believe in trading time for money. Like if somebody's wasting your time, that's my peeve. I hate that, right? I will shut it down fast. I was like, no, you're not going to waste my time, because that moment in time I never get back. Like I have loved ones that have gone on. Those moments are gone. You see what I'm saying? Even though we're always in the eternal now, but the time we have with our loved ones trumps everything, because before you know it, you're going to blink your eye, and then next thing you know, your loved ones are gone. And then what have you been doing? Chasing the dime, or have you been living your life? So it's like, this is why I am where I am. It's like, I don't want to waste my time chasing the bag and then spend all of my time going to a job that I hate or thinking about money. It was like, no, I need to live my life while I'm alive. You see what I'm saying? Because there's a reason that I'm feeling this way and that I want to do this stuff. I need to nurture it and follow through on it. So that's enough of me ranting, being on this thing. Hopefully you got something out of it. Thanks for the words of encouragement. I appreciate it. Anybody else there? Any other questions before we pop out? Going once, going twice. All right. So on that note, we're officially going to end the session here. And from one beautiful mind to another, enjoy the rest of your day, guys. Take care. Peace.
You too, Dr. Phifer. Thank you.
Yep. All right.